Hello students. So today we are going to discuss about vertical circular motion. Vertical circular motion. Vertical circular motion. So vertical circular motion is a topic which combines with conservation of energy concepts and force concept. So this involves both the force and energy concept. So let's understand this. So let us say a body is going in a circular motion. Okay. So there is a body, and this body, how it is, so you can consider this as a string, and this is the center of the string, and this body is going, and let's say at the bottom this speed is, let's say, v1. Okay, then at any general point making angle theta, what will be the speed? Okay. We want to calculate the speed at this general point. So let's say this speed is v here. Let's calculate this speed. So energy conservation, how to apply energy conservation? So first of all, this is radius r, this is radius r. You drop here perpendicular, right? So this distance from here to here, that become r cos theta, and this become r sin theta. We know that, right? So this is the height which you can consider, which will become r minus r cos theta. How this is r cos theta? Because from here this to this much length is r cos theta, right? And the total is the radius r. So that's why this is h, right? This is h. So h is equal to, or you can say r cos theta plus h is equal to r, right? Total radius. So from here h you get. So between these 2 points you can apply the energy conservation. Let's apply energy conservation. So at the bottom point, kinetic energy plus potential energy remains constant, right? This is what it is, energy conservation. So by energy conservation, we can apply this concept first. Okay. Which energy? Here of course mechanical energy. We are not considering any friction or other thing. So kinetic energy at the bottom, half m v1 square, right? And there is no potential energy at the bottom, that's the reference level, so 0. Finally potential kinetic energy half m v square. V is general V, and height is mgh. So simplify from here, v1 square will become v square plus 2gh, right? H is r 1 minus cos theta, you can take. So from here if you calculate v will become root under v1 square minus 2gr 1 minus cos theta. So this is the formula for speed at any angle. At any angle we can calculate, and of course speed at the bottom should be given, right? Now we should try to also think about the tension, how tension and other things are changing. So let us say this was the bound, and at an angle of theta, how things are changing. So there will be tension in this direction, mg in this direction, and let us extend this angle is theta. Mg can be resolved into 2 directions along the radial direction, outward mg cos theta, and this is mg sin theta. And let us say here this object has some velocity v. Okay, so it's going in a circular path, isn't it? So net force towards this center is called centripetal force, right? So tension minus mg cos theta will give us mv square by radius, right? So tension we can calculate mg cos theta plus mv square by r. This is how tension will vary. Tension will vary like this. This we have already seen, right? And similarly, what about the acceleration? So there will be 2 direction acceleration. Of course, if there is a acceleration in a circular motion, there will be centripetal acceleration and there will be tangential acceleration. Two accelerations will be there, right? And the resultant of these two accelerations will be the net acceleration, right? So net acceleration is root under AC square plus AT square. This we have seen in non-uniform circular motion, right? Here centripetal acceleration is v square by r or omega square r, and tangential acceleration is dv by dt. Rate of change of speed or r into alpha, right? So this already we know. Okay, so these concepts will be used. So let us now understand the calculation of critical velocities. Critical velocities. Critical velocities. So what are critical velocity? To the velocity at any point, such that the body just completes the circular motion, vertical circular motion. It is just able to complete VCM. Okay, so let's take at the bottom, right, and at the top. So what is the condition for critical velocity? Condition for critical velocity just completing means tension at the topmost point, tension becomes 0. That's the condition. Okay, tension becomes 0. So instantaneously tension becomes 0, but immediately tension is gained because it moved to the other side. So what is the speed at the bottom? V1. What is the speed at the top? Let's say V2 or any other place we can calculate. So if you take at the topmost point, the forces acting is first of all mg, there is no tension. This is the mg which is providing centripetal force. So mg is equal to mv square by r. So from here v square becomes gr and v becomes root gr. So critical velocity at the top must be root gr. Of course this v is v2, right? This v is v2. So critical velocity at the critical velocity is at the top is this. V2 is equal to root gr. V2 is equal to root gr. Okay, that's the critical velocity at the top. Then we can calculate V1, apply energy conservation at the bottom, half and V1 square, and potential energy 0 at the bottom, and the kinetic energy at the top, half and V2 square. Potential energy, so this height is equal to 2r, right? So this is mg into 2r. So at the bottom we will calculate, right? So from here it is V1 square, V2 square plus 4gr. Now substitute V2. So from here V1 square becomes gr plus 4gr. So that's why V1 becomes root under 5gr. So the condition under which it can undergo a complete circular motion, just complete circular motion is this. So if V is less than root 5gr, it will not complete a circular motion. Okay. So this is the condition for just completing a circular motion, just completing a VCM, vertical circular motion. Okay, that's what it is. So at any point we can calculate the critical velocities at any point, at any angle, right? Now let us take some case studies here. What will happen if the pendulum has velocity less than root 5gr? Now less than root 5gr can be something can happen. Let us try to understand. So let's see the condition for oscillation. Condition for oscillation. So So suppose if you consider a bob or an object, right, and let's say you give some velocity here v1. Oscillation means it should come maximum it can go to 90 degree, right, and then it will oscillate this side. So maximum angular displacement, so this should be considered as extreme position. Actually it should be less than this, but let us consider extreme position this. So if you consider this as extreme position, so here this speed must be 0, right. So let's apply energy conservation here. So this is the radius r. So bottom v1 square, potential energy 0, at the top potential energy is mgr, kinetic energy is 0, right. Kinetic, so first you write kinetic energy which is 0, then potential energy mgr. So from here v1 we get v1 is equal to root 2 gr. Okay, so the speed here should be less than root 2 gr, isn't it? So speed should be less. If it is greater than root 2 gr, then it will cross this point. So speed v1 should be less than root 2 gr for the condition of oscillation. Let's say they have given v1 at the bottom is root gr or root 1.5 gr. That means it is under oscillation. We should directly tell that. Okay, right. Then let's see other condition. So second condition, if velocity at the bottom is greater than root 2 gr and it is less than root 5 gr, then what will happen? So it is the condition in which the bob will of course cross the horizontal position and it may go somewhere here, right. In a circular motion it will go somewhere. This is the radius r. Then what will happen? Then at this point it will have, it will go up to some height, but what can happen is that at some point the tension can become 0, right. So if tension becomes 0, then this bob will be thrown off, right. So then it can enter into like this, a projectile motion it can enter. So it may go like, so if this was the circular path, let's say this was the circular path, right. So this body can enter into projectile motion whose path can be like this. Okay, because here tension becomes 0. So during this to this instant tension will be 0. Tension will be 0 during this path. This is the path I am saying. So it will leave the circular path. Okay, this is the condition for leaving the circular path. Condition for leaving the circular path. Okay, so here tension becomes 0, so some angle will be there where it can happen. This angle theta, vertical. We can calculate that. How? So you can take this height. So this height will be r cos theta, and this height is r. So apply energy conservation. So at the bottom v1. So half m v1 square, potential energy 0. And at that point, let's say speed is v2. So half m v2 square, right? And then this potential energy mg h is r1 plus cos theta, right? 1 plus cos theta. Now if you try to open this, what do you get? v1 square is equal to v2 square plus 2 gr 1 plus cos theta. Okay, theta is measured from the vertical. So now also we can see at this point how things are taking place at this point. So if you draw the forces, now tension is 0, only force is mg acting here. So this is also theta. So in this direction, this component of force is mg cos theta. mg cos theta. So this mg cos theta is acting as a centripetal force. So mg cos theta is equal to mv square v2 square by r. So from here we get v2 square. v2 square is gr cos theta. So let's substitute here v2 square. So v1 square is gr cos theta plus 2gr 1 plus cos theta. Right. So from here we can calculate. So let us take, so 3gr cos theta will come plus 2gr will come into v1 square. So from here we can calculate cos theta. Cos theta will be v1 square minus 2gr divided by 3gr. Right. Remember, this angle is with respect to this vertical in this direction. If you want to calculate this angle, this will be 180 degree minus theta. So cos of 180 degree, let's say this angle is 5. So cos of angle phi is what? It is cos of 180 degree minus theta. Cos of 180 degree minus theta is minus cos theta. So this will become 2gr minus v1 square by 3gr. Correct? That will be cos phi. And if we have to calculate phi, that will be cos inverse of this 2gr minus v1 square divided by 3gr. Okay. This formula can also be remembered, or in some questions we can use this directly. Okay. So this is about vertical circular motion, different concept, right? And tension is maximum, minimum, where we can calculate. At the bottom tension is maximum, at the top tension is minimum, right? So these are the important concepts that we can use in the problem. So with this, these concepts are over in this chapter. Then we will be taking up problems. Okay. Thank you for your attention.